Hello students, welcome to video lesson 5.8. This is going to be our last video lesson in chapter 5. Just again, reviewing area and perimeter and things like that. In this video, we are going to make our lives a little bit more complicated by finding the area and perimeters of what we call composite figures, which basically means we're taking two different shapes and we're putting them together into one figure. So when we look at them and try to find their areas and perimeters, we're just going to basically divide them back up into the shapes that we've been talking about in chapter 5 and find their areas or perimeters in that way. Okay, so if I look at this particular figure, which sort of looks like a house that's been starting to tip over a little bit, we should recognize that this figure is basically made up of a triangle and a parallelogram. Okay, and both of those are things that we know how to deal with in terms of area and perimeter. Now, if we start with the perimeter, it is important to note that when we divide the shape, like with a dotted line or dashed line, or if you put any division lines in there, you don't get to count those for the perimeters, right? Perimeter is strictly the outside of the original figure. So in this case, that would be, this side, this side, this side, this side, this side, right? So if we put some information in here, some values that maybe are given to you in the problem, let's say that we are told this is 6 inches, and this is 5 inches, and this one is 9 inches. Based on those three pieces of information, I think we can find the perimeter of this figure. It's not enough to find the area because for both parallelograms and triangles, we need the height, and none of this stuff looks like it hits at 90 degrees. But this is enough to find the perimeter because I've been given 3 of my 5 side lengths here that I need to add together. So obviously I have a 9, I have a 5, I have a 6. And then this one over here, the other side of this triangle, is marked as congruent to this side over here. So that one must also be 6 inches. So plus another 6. And then this side over here, because this is a parallelogram, the opposite sides have to be congruent. So remember that if this one is 5 over here, this one is also 5 over here. So we would get to do that. If we add all of those together, we get 31 inches for my perimeter. Okay, and again, perimeter is just in regular inches, not any squared inches or units like that. So finding perimeter, remember that parallelograms have congruent opposite sides, as do rectangles. And also remember that any lines that we put in there ourselves or any lines that show up dashed in your book do not count for perimeter, okay? So if I then want to look at the area of this particular figure, the 6 inches up here on the triangle are not actually helpful for me for that. And neither are the 5 inches sides on the parallelogram. Because again, I really need bases and heights for both of these shapes if I'm going to find their areas. So one thing that I recognize is that 9 inches is the base of this parallelogram. So I would have to be told what the height of the parallelogram is here in order to find the area of this part of the shape. So if, for example, we're told that that is, let's say, 4 inches, now we have enough information to find the area of the parallelogram, right? Base times height. We don't have to divide by 2 for a parallelogram, so this is 36 square inches. Okay, and then in terms of the triangle, my base here of the triangle is sort of this dashed line that I've drawn across the shape. So that dashed line then is 9 inches because the opposite sides of the parallelogram have to be congruent to each other. So if I know one, I know the other. And then again, I would just need to know the height of this shape that hits at 90 degrees. And let's say we're told that that one is 2 inches. Okay, so then I can use my formula for area of a triangle, multiply the base times the height, and then divide it by 2. 9 times 2 is 18. divided by 2 is back to 9 inches squared. So I get this piece, I get this piece, and so my final total answer for the area of this composite figure would be the sum total of those two pieces, which is 45 square inches. Okay, so when you're finding area of a composite figure, you need to split it up into shapes that you know the area of and hope that you have the relevant pieces of information that you need then to find the values or the areas of each of those pieces, sum them up together, and you've got the area of the whole thing, okay? If you have questions at all about composite figures, you are going to need to know squares, rectangles, trapezoids, triangles, parallelograms. All of those will come into play in your practice problems. Let me know if you need any help. Otherwise, that's all I have for you right now, and we'll talk to you soon.